So, today we're going to be talking about triangle proofs. Specifically, we're going to go over the following 5 theorems: side, 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 angle, side, angle, side, angle, 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 side, and hypotenuse leg. That's what those abbreviations mean. Okay, our essential question. What information about 2 triangles allows us to conclude that the triangles are congruent? We'll be applying the theorems to construct triangles to solve problems, and we'll be proving triangle congruence using our theorems. Make sure you've got key terms down: triangle rigidity. Triangle rigidity, included angle, included side. Triangle rigidity, Just run roll off the top. Oh my arms. What is that like? Spanish sounded like I can't roll my arms. I can't allow to do that. Alright, if you need it, we'll come back to it. Ready, steady, go. Property of triangle rigidity gives you a shortcut for proving triangles are congruent. So go ahead and what? Okay, I would write down triangle rigidity and say if the side lengths of a triangle are given, the triangle can have only one shape. That would be triangle rigidity. And if you think about it, it makes sense. If I give you all the side lengths of a triangle, then I told you everything you need to know about the shape of the triangle, right? Think about it. If you're making a, I don't know, you're making a door frame, a bad example probably, but I just gave it to you. If you make a door frame and I say, hey, I want this door frame to be 4.5 feet by 10 feet all the way around, I've given you how big the door frame is going to be, correct? It's like if I give you side lengths of 10 inches, 12 inches, and 15 inches of a triangle, I've given you how big the triangle is going to be. The first postulate that we're going to talk about: side, side, side. Side, side, side congruence postulate. Write down our definitions. Make sure that you write down all the stuff I've got circled or underlined. Okay, my side, side, side congruence postulate says 3 sides of one triangle are congruent to 3 sides of another triangle. Then the triangles are congruent. In their example, triangle ABC is congruent to triangle FDE. Notice that A to B is 4 centimeters, B to F is 4 centimeters, B to C is 6 centimeters, and B to E is 6 centimeters. A to C is 7 centimeters, and F to E is 7 centimeters. Okay. Side, side, side. How many sides do I need? All 3, right? We won't work. Gotta have all 3 sides congruent to both triangles. Okay. Check it out. We already have, I think we've already defined this, so you don't necessarily have to define included angle again. I just want to make sure we understand it. Included angle is an angle formed by 2 adjacent sides of the polygon. Angle B is the included angle between between sides AB and BC. Okay, so when I say the included angle between AB and CB, that's the only logical answer. B, correct? What would be the included angle between BA and CA? A. What would be the included angle between AC and DC? Okay. Luckily for you guys, in a triangle, how many angles do I have? Three. So angles have to be either included or excluded, right? We call them remote. Okay. But yeah, you're either in or you're not. That's kind of the deal. There's not like a okay. Oh, that gets us to this particular theorem, our side angle side congruence postulate. Okay. If two sides and the included angle of one triangle are congruent to two sides and the included angle of another triangle, then the triangles are congruent. If two sides and the included angle of one triangle are congruent to the two sides and the included angle of another triangle, then the triangles are congruent. This one can be kind of confusing sometimes. Side angle side can be confusing sometimes. So I'll do my best today to work you through that one, okay? What's going to end up happening? Well, I won't give it away. I'll show you as many tricks as I can. Okay, so in this example, angle A is included between sides BA and CA, and that's congruent to angle A is congruent to E, BA is congruent to FE, CA is congruent to DE. So the side angle side postulate tells me that the two triangles are congruent to each other. I don't know. Okay, an included side. I'm gonna write this one down. Okay, I would write down our definition here. Okay, an included side is the common side of two consecutive angles in a polygon. Okay, we're going to talk about the postulates that we use this with, right? But their example here, PQ is the included side of angle P and angle Q. So this was kind of hard to visualize sometimes. But you always, when you look at a triangle, you typically see sides and not angles. You actually got to kind of view this from an angle viewpoint. What side of the triangle is between P and Q? PQ, correct? What side of the triangle is between angle P and angle Q? PQ. And it's kind of like, well, yeah, no, duh. But then it's harder to visualize sometimes. You typically won't look at a triangle and say, okay, so this side length is between these two angles. Because we just taught you to think about it. This angle is between these two sides. So it goes both ways. Okay. Couple more seconds here, you got it? All right. But we do get this out of it. My angle side angle congruence postulate. Two angles and the included side of one triangle are congruent to two angles and the included side of another triangle, then my triangles are congruent. Oh yes. 3 of 5. You got 2 more after this one. two angles in the included side of one triangle are congruent to two angles in the included side of another, then my triangles are congruent. Okay, so angle side angle has a cousin, so paired with it. It's called angle side. Okay, but I want to take a look here, make sure we understand it. What I understand is that AC, the side of the triangle, AC, is between angles A and C. Yes. It's the foundational step that you got to take to get this, okay? But then we go into this, and we say angle side. If two angles in a non-included side of one triangle, two angles and a non-included side of one triangle are congruent to the corresponding angles and non-included side of another triangle, then the triangles are congruent. So, check it out here. Side HJ and side LM are not between the congruent angles. They are non-included sides, but I have this postulate, angle side, which leads me to conclude that the two triangles are congruent. This is the one where it kind of gets a little tougher to see and visualize. Now you got a really good pick that off. Plus, it all has to go in order. So far, let's talk about it. Let's do a quick review here. Three sides of the triangle. Three sides of the triangle. Two different triangles. Side, side, side. Gives me congruence. Side, included angle, side, in both triangles. Give me congruence. Angle, included side, angle side, in both triangles. Gives me congruence. Angle side, in both triangles. Gives me congruence. And we get this. This is called hypotenuse leg. Hypotenuse leg. So, if the hypotenuse and a leg of a right triangle are congruent to the hypotenuse and a leg of another right triangle, then my triangles are congruent. Well, Ethan.
What's that H one?
Hypotenuse.
Yeah, what does it mean?
So basically what you're saying, all triangles.
No, that is not at all what I'm saying.
Because everything.
Jumper is not on top. I didn't say that. I said no.
It is called hypotenuse. And what the hypotenuse is, you'll look at it. The hypotenuse is only in a right triangle. It is opposite. It's on the opposite side.
Is it a long one?
It's the longest side of a right triangle. It's opposite of the right angle. You will be really quick in that. Yeah, so next unit is all about right triangles. Okay? Next unit is nothing but right triangles. Trigonometry, Pythagorean theorem, all that good stuff. Okay? And so you'll get used to matter of fact, you'll start having brains about hypotheses. Okay? Really strange. Yeah, you'll have these crazy brains. Yeah, but I'm not. You write this down? Okay. So, if I have congruent hypotenuse and a congruent leg, two different triangles, I've got congruent triangles. Between the two triangles. You guys still need it? Okay. Hi guys. Now let's go over. Hey, let's go over a couple of these. Okay. It says determine if I can use angle, side, angle to prove the triangles are congruent. Then I have to explain. Okay. So what do I have to have for angle, side, angle? An angle, a what? A what type of side? Stop. Listen to my question. To use angle, side, angle, I have to have an angle, a what? Included side, and another angle. These triangles have a side in common. Yes. Yeah, they do. This side right here would be congruent or common to both triangles. Okay? Yes. No. Well, yeah, that's my point. So if I was going to use angle, side, angle, what side would have to be congruent? The long side. This side right here, correct? Do I have any information that would be able to tell me that that's congruent using angle, side, angle? No, I don't. Okay? Because it's not the included side that's congruent, it's the non-included side. So if it's the non-included side, which theorem would I have to use? Angle, angle, side. Angle, angle, side. If you ever get confused, just say it out loud. What's this? Angle, congruent angle, side. Angle, angle, side. So this side that they share is always going to be congruent because of the reflective property, correct? In both triangles, this side is the same. Since it's the same, the reflective property tells me it's congruent in both triangles. Okay? And no. If they're not connected, then no, I don't have reflective property. Right? What about side, side, side here? Okay, three sides of one triangle are congruent to three sides of another triangle. Right here, how many sides am I given? Two. But the last B and C are. All right, guys, just give me a second. Okay, listen to my questions and then say something. I'm only given two sides of the triangle, but using the same reflexive property that we used in the last problem, Tyler, what can I conclude about B and C? They're congruent to each other, correct? In triangle ABC and in triangle BBC, BC will be congruent in both those triangles. So if I symbolize that, how many sides do I have congruent now? Three. How many do I need for side, side, side? Three. Okay. That's the way these problems will work. Side, side, side. Okay. Use side, angle, side to explain why ABC is congruent to DBC. Guess what's happening again? Same thing. Is BC congruent to itself in both of these particular triangles? Yes, it is. The reflexive property tells me that BC in triangle BBC and ABC, BC is congruent. It's congruent to itself. If I split the triangles apart, I'd have BC in one, BC in the other. Right? You take a pizza. Correct? Take a pizza. Careful, right? This side of the pizza, right here, of this slice of the pizza, right? You got me? This side right here. I take that pizza apart. The side of slice 1 is the same as the side of slice 2. Correct? It doesn't matter if I cut it. Even if I cut it like this. Look at this one. 7 and 8. This side length right there, that side length is going to be the same in 7 as in 8. Okay, so it makes them congruent. Yeah. And then I've got side, angle side, and included angle. Side, angle side, with an included angle. And side, angle side is one of my 5 congruency functions. This is what we'll be getting to. Ray QP bisects angle RQS. QR is congruent to QS. Prove that prove the triangle RQP is congruent to triangle SQP. Well, if it's an angle bisector, I said this over and over again in this class. Hope you're picking up on it. An angle bisector splits or divides an angle into 2 congruent angles. And QP, in this particular example, there's a reflexive property, is congruent to itself in the 2 triangles. Side, angle, side. Right? Okay. All right, that is pretty much most of the lesson. Here's an example of what you would see with hypotenuse leg. Okay, check it out again. I'll always point it out. Determine if I can use hypotenuse leg here. I can. My hypotenuse is opposite the right angle. Always opposite the right angle. What would be the other 2 sides of a right triangle are called the legs. Which one of these legs would have to be congruent? The base, the bottom legs, or the vertical legs? Because of the what? The what? The reflexive property tells me that side of the triangle on the left has to be the same triangle on the right. Okay? Notice how many times we're using the reflexive property. A lot. Correct? A lot. So what we'll end up learning is called CDCTC, corresponding parts of congruent triangles are congruent, which means that once I use one of my 5 theorems that we talked about today, CDCTC, tomorrow. Once I use one of my 5 congruence postulates, after that I've proven that the triangles are congruent to each other, CPCTC stands for corresponding parts of congruent triangles are congruent, which means that once I get this particular problem solved, once I get that the 2 triangles are congruent, all the other angles and all the other sides are congruent. Okay? It's not that bad. You got to get through this first. Okay? Are there any other